So today we're going to explore a world that, well, it might not even exist. It's a planet of such wild extremes that it's been called the planet with two tails. This is the incredible story of Gliese 581g, a scientific puzzle that really pushes the limits of how we find new worlds out there in the cosmos.
Okay, just try to picture this for a second. A planet that's permanently split right down the middle. One half is forever facing its star, a wasteland so hot it could literally vaporize rock. And the other half, it's trapped in a never-ending deep freeze night, with temperatures that are getting awfully close to absolute zero. Now this sounds like something straight out of sci-fi, but it's the predicted reality of this place. So how on earth does a planet get stuck like that?
Well, it all comes down to a phenomenon called synchronous rotation, or as it's more commonly known, tidal locking. You've actually seen this before. It's the exact same reason why we only ever see one side of our own moon. Because Gliese 581g orbits so close to its star, the star's massive gravity has basically grabbed hold of it and stopped its rotation relative to its orbit. And the result? One side of permanent day, one side of permanent night. It's two extreme tails.
But before we get into the absolutely wild climate, we have to talk about how we even thought we found this planet in the first place. Because the story of its discovery, it's like a masterclass in learning how to listen for the tiniest, faintest whispers from the stars.
See, scientists didn't just point a telescope and see the planet. That's not how it worked. Instead, they used a really clever indirect method called the Radial Velocity Technique. What they're really doing is watching the planet's star, and they're looking for a tiny, rhythmic wobble. You see, even a small planet's gravity is strong enough to give its massive parent star a little tug, making it move back and forth ever so slightly. So here's the breakdown. The orbiting planet pulls on its star, causing that little wobble. Now, as the star wobbles toward us and then away from us, the light coming from it gets slightly compressed, then slightly stretched. It's the same Doppler effect that makes an ambulance siren change pitch as it passes you. By measuring that tiny shift in the starlight, astronomers can tell an unseen planet is there, and they can even get a good guess at its mass.
And the level of precision we're talking about here is it's mind-blowing. The wobble that Gliese 581g was supposedly causing in its star was measured at only about 2 meters per second. That is literally the speed of a person taking a brisk walk. Being able to detect that tiny motion in a star that's 20 light-years away is just an absolutely incredible achievement of engineering.
So you can imagine the excitement when the announcement came in 2010. It was huge. Not only had they found a super-Earth, a rocky world a few times bigger than our own, but it looked like it was right in the middle of the Goldilocks zone. You know, that perfect orbital distance where temperatures could allow for liquid water. For a moment there, the world thought we might have found our first, truly habitable exoplanet. But then, the story took a really sharp turn. That beautiful, clean signal that seemed to promise a whole new world started to look like it could be something else entirely. Maybe it was just a ghost in the machine. And this is really where the scientific drama begins. The original discovery team, using data from the Lick Carnegie survey, was absolutely confident in what they saw. But then, just a few years later, a completely different team using a different instrument called HARPS took another look at all the data and they couldn't find it. They argued that the signal wasn't a planet at all. All of a sudden, the scientific community was at a major crossroads.
So they came up with this counter theory, which became known as the stellar jitter hypothesis. The basic idea is that the star itself, Gliese 581, isn't perfectly stable. It's magnetically active, meaning it has things like giant star spots that rotate across its surface. And that activity could create a false signal that looks almost exactly like the wobble of a planet. So the big question became, was this amazing discovery just an echo of its noisy, jittery star?
And that, right there, is the central mystery that has divided astronomers for more than a decade now. Is this incredible world with two tails a real destination we can put on our cosmic map? Or is it nothing more than a phantom, a ghost born from stellar noise?
The debate is definitely still raging. But you know what? Let's just for a moment, let's step into the what if. Let's assume Gliese 581g is real, and let's explore what this unbelievably bizarre world might actually be like.
Okay, so first things first. If it does exist, almost none of it would actually be habitable. You can forget about the scorching hot day side and the frozen solid night side. The only potential real estate for life would be this tiny, tiny sliver of the planet's surface. This narrow little strip of land has an awesome name, the Terminator Zone. It's this permanent ring of twilight that circles the entire planet, forever caught between the blazing light and the absolute darkness. And it's right here, in this perpetual sunset, that temperatures might be just right for liquid water to exist, making it the one and only place where life, as we know it, could maybe get a foothold.
But even in that twilight zone, the planet's ability to host life would be balanced on a knife's edge. It's facing two constant killer threats. On the day side, there's the risk of a runaway greenhouse effect that could boil away every last drop of water. And on the night side, the atmosphere itself could literally freeze and fall out of the sky like snow. So any chance for life depends entirely on having a perfect atmosphere that can move just the right amount of heat around the globe.
And just to put this world in perspective, it's thought to be at least 3 times more massive than Earth, and it whips around its star in less than 37 days. So a year on Gliese 581g is barely longer than one of our months. It is a truly profoundly alien world in every sense of the term.
So after all of this debate, all of this modeling, where do we actually stand today? What's the final verdict on this unsolved cosmic case?
Here's the fascinating thing. Whether Gliese 581g is real or not, its story became a hugely important moment for science. This whole controversy forced astronomers to get way, way better at telling the difference between a real planet and just the noise from its star. It was a massive wake-up call that taught an entire generation of scientists to be more careful, to be more rigorous, and it fundamentally changed how we search for other worlds.
And the good news is, we actually have a game plan to get a final answer. To really solve this case, scientists need to use new techniques to perfectly filter out that stellar jitter. They need to try and spot the planet crossing in front of its star, which would confirm its size. And they could use incredible tools like the James Webb Space Telescope to literally map the heat flowing from the hot side to the cold side. That would be the smoking gun.
And that really leaves us with one final big question. Is Gliese 581g just a cosmic ghost, a false signal that led us on a wild goose chase for a decade? Or is its incredible story, with all the challenges and all the strange possibilities, the very roadmap we needed to follow to find the next truly habitable Earth? For now, the search continues.